Ludi, thanks for hopping onto the call. I wanted to take a little bit of time to talk with you about some of the work you've been doing on the multi-jet fusion recently. I know you've been working with a lot of Phasio customers on setting up pricing for the multi-jet fusion to enable them to perform instant quotations. First of all, can you start by talking about what it is you do at Phasio and sort of how that interacts with what you're doing with multi-jet fusion?
Of course. Thank you for having me here, Harry. I'm very happy to chat a bit about that. So at Phasio, I'm the chief of staff, and I'm sort of taking care of a lot of the customer interaction that we have, just speaking to service bureaus, speaking to contract manufacturers, and trying to figure out what they need in order to perform better. Because the vision that we have really is we want to empower local manufacturers to deliver products to market. And as most know in this space, there are a couple hurdles, and some of these hurdles are really not necessary. And one of them is, for example, spending a lot of time on things that could be automated. Because ultimately, if you want to provide the best service to your client, you got to spend time with your clients, right? But time is a very precious resource most of the times, and so it's very important to automate as many steps as possible. And pricing in particular is one that is really interesting, and my background in physics and math kind of helped me to just dive into that space really deep. And ultimately, the MJF technology is super fascinating. The people using it are super motivated, which is why I'm drawn to this technology, just as you are as well, right, Harry?
Absolutely, yeah. I think we should start by maybe just summarizing, like mechanistically, what is the multi-jet fusion, and also how it works, how it differs from other 3D printing and additive technologies. So to begin with, do you want to explain a little bit about the mechanism of how the MJF works and how it compares to some other machines?
All right, let's just look at this in the most simple way. So it's a powder bed-based machine. So you basically print parts layer by layer. But other than in like FDM, where you have like an extrusion process just going on a line and just extruding material, you have a powder bed where locally the powder is actually wetted with an ink, and then there's a curing step where some like a light source is basically curing the parts where the powder has been linked by the liquid. And it's a similar to like, it's by HP, right? So they used a lot of their IP from the 2D printing in order to transfer that to the 3D printing space. And building up these prints layer by layer and always having, like this ink step and then the curing step, the box goes down, there's the next layer of powder being applied, and then again the wetting and then the curing is ultimately leading to parts that have extremely smooth surfaces. And like due to the fact that we work in this technology with mostly PA11 and PA12, there's also the option for TPU, but you see these are like the first were nylon, and these are like very high grade polymers, and they produce pretty tough parts which can be used in a variety of different, more like industrial applications, which makes this technology really interesting for a lot of like businesses that are more towards, say, industrial sector.
Well, that's one of the interesting things about the multi-jet fusion, right? It's that there's a $1 trillion industrial products and services market, which is the MJF is uniquely positioned to serve, right? Because it's able to print high volumes of industrial products, whereas like some other machines, for example, metal machines, are much better tailored for aerospace and high performance vehicles, but they're not really designed for the same volume throughput that something like the MJF is, right?
Yes, certainly, because you have a lot of, again, automations, a lot of options for automation in the MJF process. And actually, this reminds me of a story when I visited a company that has the MJF process left, right, and center in their company. And they told me that they went out to their clients and actually presented them parts made through typical FDM, so that's the extrusion technology, through SLA, that's like with working with resins and curing those resins, and also the MJF and SLS process. And all of their clients, they said, wow, like the MJF parts are by far the best in terms of touch and feel, terms of toughness, in terms of quality of the part, in terms of also tolerance, so the size conformity. And this company was immediately like, okay, well, we got to invest in the MJF technology if we want to serve our clients as the utmost best.
That makes sense. Okay. Now that we've got a bit of a picture on some of the differences between the process, can you maybe talk a little bit about some of the differences you see between manufacturers? Because, I know as part of Phasio, we get to work with a lot of companies who are using various types of manufacturing technologies from CNC all the way to multi-jet fusion or even FDM 3D printing. So what's the big difference that you see with multi-jet fusion manufacturers?
Usually what I see is a very, very clean workshop, like extremely tidy, extremely clean, and extremely well planned out in terms of the process. So just think of you start at one end and you really carry the parts in a linear fashion towards the completed parts. And there might be some workstations in between, for example, vapor smoothing or like dyeing, like for the post-processing side of things, right? But this MJF process is just thought out to be like an industrial process to make parts on a very high level. So probably fewest service bureaus will ever apply the MJF technology. People that do are usually more in the base of contract manufacturing and have a very well planned out routine to make these. So I guess the biggest difference really is that sort of mindset to automate things and also just like having this extremely clean and well thought of environment, which don't get me wrong, people that use FDM and SLA and SLS can have as well, but it's just a pattern that I see with people applying the MJF technology.
What about the way they operate their businesses? Do you see differences in how MJF and FDM businesses or even SLA businesses work?
Yeah, partially. Like many people that have like it's not MJF technology is expensive. Let's face it. It's not the cheapest out there in the market. It's definitely a lot more expensive than the first SLS machines that you can get. But the people that do have the MJF machine, their parts are also wanted from many potential clients, and they often have partners a lot that give work to them just because they have the availability of the technology. And then when you say this, like, how do they work and what's the difference there? It's again this thing where service bureau versus contract manufacturer. And I have to say that these contract manufacturers, they seem to take their B2B deals just to the next level in terms of reorders, or they just want to become the manufacturer for the client's warehouse and just make sure that we're the ones you can rely on at any time and will get these parts done. Just the speed at which they can operate in terms of getting even mini series or like proper series production out for which maybe there's no injection mold anymore, right? And then with MJF, you can just pump out parts in a very well designed process. So yeah, I think people that are into automation will love this technology, and ultimately the clients they get the benefit from that.
Why do you think that an MJF user should automate their pricing using a platform like Phasio?
Yeah, there are a few points why this is useful. First of all, you want to be consistent, right? And consistent in pricing means that you build trust with your clients. And you could, of course, very well do that through some Excel sheet. But the situation that you end up with is that you get the model file and you get it through an email or whatever way. And then some personnel is going to price it. And probably if you have 10 people in your team, only one or two people are able to do that. So that's not really like a, say, efficient way of working, because if these two people are sick or on holiday, well, you basically you can't work, right? And then usually the MJF technology, people use pieces of software that do nesting, and nesting is basically it's an arrangement of 3D model files in a space, and that space should be like the nesting will just be an efficient way of putting these parts into the build volume, into the space where parts can be made. And typical softwares for this might be Autodesk NetFab or Magix, or there are also other softwares out there to do this nesting. And when people don't use like a smart equation for automated pricing, they usually have to take the part, put it into whatever software they use, maybe put a couple other parts in, do the nesting, understand how much time it takes to print that, understand the density of the nesting, so how efficient the print will be. And then they take these numbers into the Excel software, for example, or into any other calculation software. They get to a price, and then they have it. Now they send their quote out maybe through some other manual process, through, I don't know, Zero or like some other accounting software. And the customer sees it and is like, oh, maybe instead of 10, I actually want 20. And then the person has to go back, take the file, go back into Magix, do the nesting again, take the information out, and then write a quote again and send it out to the client. And client is like, oh, maybe not. And you see where this is going, right? So one person that's like heavily skilled enough to use all sorts of softwares, like nesting softwares and things like that, and they just wasted their time on sending these quotes out. And I think that's a very evident first example of why having like a reliable automated pricing is actually worth it. And if you think, oh, there's going to be errors and mistakes, that's actually not true. Man, yeah, of course, it's never going to be the same through an equation, but just imagine the amount of time that you can save from your employee work time, which they could either spend making the process even more efficient, spend with the clients, spend with the parts to make the quality just divine. There's so much opportunity in just automating this part of the business.
I think one of the things that I would like us to address is the MJF is a high volume machine. High volume means lots of parts. Lots of parts means lots of quotes.
Yeah, fair enough. That's definitely the case, and not only lots of quotes, but lots of quotes from different people. So you kind of end up in a situation where one build may have, if it's small parts, may have a few hundred parts, right? From maybe dozens different of clients, right? And like the sheer amount of paperwork, digital paperwork, of course, that is in one single build is tremendous. So it's really a challenge to keep track of all the parts and also, of course, have a competitive pricing for all of these parts. And the sort of biggest challenge that I see across every single MJF business I sort of talk to or work with is to understand what is my profit? What is my margin on each individual part? Because you end up with a built print that just ran through the machine and you know your material cost because HP sources the material for MJF users. And the way that it works is that you purchase an MJF machine, you get a contract with HP or one of the material vendors like BASF, for example, and you actually pay them for the material used per print. So if you manage to have a high density in your prints, like a packing density, right? How well the nesting, how many parts fit into the build volume, you actually can lower your material costs significantly. And the truth to understand how much money you spent and how much money you made in that process, that's extremely valuable for executives and people to plan out the company's growth plan or just business plan.
That makes a lot of sense. Okay. So then let's talk a little bit more about the pricing itself and how it differs from other technologies. So you mentioned that there's a difference in the nesting is very important in the pricing for MJF. Are there any other differences that you notice when it comes to pricing for multi-jet fusion?
Yeah, let me maybe start this question with telling about FDM. Many people in FDM, the extrusion technology, really want to get down to how many hours does the printer run and how much material do I use. And they want to like run it like that or through like volume, surface, and other contributions. But the beautiful thing in powder bed based machines, and MJF is certainly a powder bed based machines, is that the material cost is pretty clear through volume of the parts. And if you know about nesting and how well a part is actually fitting into how well a part nests, so it's fitting into the build volume, then you kind of have an idea of how much you need to charge for these parts, simply because you know the allocated space that it takes in the print. And now the interesting bit here is that it's actually not about the price for material and all that so much. It's more about when to give discount and how. Because yes, you get one-offs, of course, also in the MJF technology, as you get everywhere. But oftentimes you have serious production or even like mini series production, a couple hundred parts maybe, right? So how do you give a discount That is the bigger question that's always coming up with the people that I work with, for example.
Right. When you say a discount, do you mean is that like a discount for volume? Is that a discount for a trusted client, or is that a discount so that you can get the customer in on their first order?
I mean, that entirely depends on the business structure that the company is running. When I talk about discount, I really want to stress the fact that someone orders a one-off part, it's going to cost X amount of money. But if someone orders like 100 or 1,000 parts, you want to like give them a benefit of like ordering from you at this high quantity. So there are a few different options that companies pursue. And one that is very famous for FDM would be just like, and famous also in other e-commerce style shops, right? It's like from 1 to 5 parts, there's no discount. From 6 to 20, there's a certain discount, like maybe 5%. From 20 to 100, there's maybe 12% discount or 12.5, and then this goes on and how many brackets you want to write. But is problematic for something like MJF and not advised to, because if you have this tiny part and you put that into your this calculation tool, it will have the same discount structure as a part that's gigantic like this. The fundamental issue here is that you treat all parts the same way. So what you really want to be doing is you want to have a different discount structure for small parts as opposed to large parts, because that's when things get interesting, where you actually represent the process of the MJF manufacturing in your pricing logic. And that's something that your employee would do when sitting at Magix or at NetFab and trying to nest these parts, right? But you can do that automatically beforehand as well already.
That makes a lot of sense. Okay. So what are the major factors then that drive the prices, that drive the quoting logic for a lot of manufacturers that are using automated quotations in Phasio?
So let's first start with people that don't use Phasio. Often they actually have a volume price for material used, and that's based on the part volume. And that volume price is just reducing with increasing quantity. And it sort of connects like part size with also quantity, but it's not really efficient at, again, this difference between small and larger parts. So what you really want to be doing is, if you upload a model, you want to understand how well that nests into a certain build volume. And then from that information onwards, define something that we call a discount speed. How quickly do you want to apply which kind of discount, right? And the interesting thing is then when you upload different part sizes, you'll get a very accurate result actually for, I just recently worked with one business in Germany, in fact, and now the person has actually really well working pricing for his MJF process for single quantity all the way up to 1,000. And having that trust in an automated system, because it's an advanced way of dealing with discounts, actually enables him to save a ton of time every single day.
It seems to me that what you're saying is that for MJF, there's an increasing need to be able to quote not just a part, but also a part at volume. Because of the advantages of MJF in doing series production, it makes sense that people are going to be ordering larger volumes of parts.
Certainly. And don't get me wrong here. Like, oftentimes, the people that order larger volumes are actually not going to be the people that interact with some storefront or something like that. And those people will likely send a request through SAP, through Oracle, through email, whatever it may be, right? And then the employees of the manufacturer, they will actually receive the parts, and then they traditionally go through the process of nesting it, looking at the part, doing their thing, just using 5 different pieces of software in order to just send one quote back or one offer back, right? But ultimately what they should be doing is just taking the model, upload it into one environment, get the price estimations there. They can still change that, of course, right? But it's a very strong first go at the pricing, and then they can, with a click of one button, reply to that offer. And ultimately, you can just spend more time dealing with your client instead of working for your client, right? And we all know what client relationships actually mean, and it is ultimately more order, more happiness for the client side, which is good for the 3D printing space for sure.
Okay, that makes sense. So then, do you have any advice for people who are watching this video who maybe interested in potentially exploring something around automating their quotation logic, but they're feeling a little nervous about it.
So my best advice is just give it a start. Like if you start today, you'll be one day earlier into it than tomorrow, and there's really nothing much to lose because you can just I don't know like I usually use tools like Python and stuff like that to just get to the bottom of things before I implement something into like a proper piece of software like Phasio, and it really is about making the test case and really understanding is this actually working for me and for my business? Because every business is different. And, that's the beautiful thing about math and physics. You can just tweak and adjust parameters like to your liking pretty much.
And so if people are not willing to do that fiddling with Python and Excel and whatnot, then you're the
Well,
man.
yeah, certainly. I'd be there. Like, that's pretty much my job to help businesses and like understand businesses what they were looking for, and then I help them to achieve these things in a efficient manner. So drop me a message, drop Phasey a message, and we'll be happy to discuss your needs and see maybe we have a solution for that already up our sleeve. Maybe not. Maybe we need to develop something. This reminds me of a story of a company in America that we work with. They're using the LSPC technology, which is similar to stereolithography, but their pricing was just a bit special. So we did some quite advanced work on fitting certain parameters regarding the bounding box parameters with the square root function to get to certain parameters. So we can get really, really into details here. And I guess most of you will not know what the convex hull volume of a part is, but it's very efficient to actually look at complexity of a model as well. And there's so many different parameters that we can infer from 3D models natively at Phasio that is just fun to play with.
I'm glad you find that stuff fun, Luddy. It's a it's a mind bender for some people.
No, no, that's all good.
So look, let's close this up, right? Like you've worked with a lot of multi-jet fusion businesses before. You've worked with a lot of other additive businesses before. What advice do you have for a company that's, maybe just purchased or looking at purchasing a multi-jet fusion, and they are trying to figure out the business case of how they're going to commercialize that machine when they get it? What advice do you have for them that you want them to take away from this video?
Spend time with your customers, understand what they really need, maybe even spend in-person time. I know it's not a thing anymore since COVID, but it usually does wonders. And then take them on the journey. Be open about it. Tell them, look, we're using a certain algorithm that does pricing for us, and I want to involve you in that such that you understand what's happening. Because everyone wants to just not pay as much for their parts, of course, right? But you can actually help your clients to design parts in a way that they won't be as expensive, right? For example, if possible, thinner some walls here and there. You'll use less material, things like that, right? Or just help them to make the best parts within your machine. And ultimately, you know how to make the best parts in your machine. And your clients will heavily appreciate that.
Excellent. All right. Well, Ludwig Hendl, thank you very much for your time. It's been lovely to chat, and let's leave it there.
Awesome. Thank you very much for having me here, Harry.